Hello everyone. So in this tutorial, we will discuss the problem whatever was given in the lecture number 10. Okay, so in this circuit, we simply change the position of R and C, and in the way we are applying the inputs as usual we were doing for uh, the location of R and C previously we have discussed. Okay, so the input is pulse here, and I think two conditions are also given there. So conditions I should also mention here. One, T is much less than RC and T is much greater than RC. Two conditions are there. And third, you can also consider T equal to RC. Or I mean to say T by 2 equal, better to say T by 2 equal to RC. It's just a case you can consider, but our importance is to these two cases. Okay, so I'll try to solve in the way whatever we have discussed till now. Let's simply we'll consider what will happen at different instants, what will happen with the capacitor voltage, and accordingly the output voltage. Okay, so let's proceed. If I'm considering the case when my T is much greater than RC, in this case we are giving much time for charging the capacitor. Okay, much time for capacitor charging. Okay. So T is much greater than RC. You can consider T by 2 is also much greater than RC. Okay. So simply what is happening at T equal to 0 positive, I will say, what will your circuit? Or circuit will be like we are applying some sort of step, just like a 0 to 5 volt. And as you can see, T by 2 is much greater than RC. So the one plot I will drop here, like I can consider T by 2 somewhere here, let's say, and T somewhere here. So the time axis. And RC is very less. So what we can see, what will happen at T by 2, I can consider that my V out, because my capacitor is shorted. Okay. So VC we can consider 0, or cap is shorted. Cap is shorted. And initially there is no charge, as I am not giving any charge, initial charge at the capacitor. So we can consider VC is 0, cap is shorted. Simply my V out is what? V out is V in. This is as usual discussion. So it is nothing but a 5 volt. Okay. So my output is starting in the 5 volt. So what is the initial current? Because we always see what is the initial current when we start the discussion. So at this point, my current across the capacitor, or it is same as the resistor current. So I should say this, or I should say this, the same thing. What is series current? Okay. So what is the value of this current? This current's value is 5 by R, means V out by R simply. That is the current. Okay. So what is the slope? Capacitor voltage slope at this point. Okay. I should say slope or capacitor voltage slope. You all know because you are already following the videos. So you know what I mean to say the initial slope. Initial slope means the charge or the current around that instant by capacitor value. So it is what? V out by RC, V out around that instant. So it is what? 5 by RC. So this is the initial current which will charge my capacitor. Okay. So let's see my capacitor is charged, and initially I am saying that this is my V out. I'm not drawing VC. You can consider my when I VC is initial 0, so my V out is 5 volt. Okay. So let's say after some time instant, which is much lesser than TI2, but it is around, like I should say, some T naught instant. Okay. So this is T equal to T naught plus, where T naught is what? T naught is much lesser than TI2, but T naught is greater than 0. Okay. So this is a time instant somewhere after my 0 point. It is here after the 0 point, but is much lesser than T by 2. Yeah. Okay. So it is our V out, which is initially 5 volt. Okay. So what will happen around this instant? I'm considering that with my initial current of, what was my initial current? With the initial current of 5 by R, initial slope of capacitor voltage is larger. Initial slope is larger 5 by RC. So the capacitor will charge with some higher rate. Let I say at T naught, my capacitor is charged to, I should say, around this voltage, my capacitor is charged to 1 volt. Let's say this is my VC. So my V out will be what? V out will be at T naught positive will be what? 4 volt, which is V in minus VC. Okay. This V out is what? V in minus VC. Okay. So again you will see this IC T0 positive or IC same as IR T0 positive is what? 4 by R. So what is the slope? Slope around this instant is what? Capacitor current by capacitor value is 4 by RC. So we can say the amount of the capacitor current which is charging the capacitor is decreasing slowly at every coming instant. When we consider some other instant, this is discussion we already have seen many times. These are the instants where T2 is greater than T1, greater than T naught, which is greater than T 0, 0 second. Okay. So this way we are seeing that amount which charging the capacitor is slowly reducing. It means the capacitor voltage slope is reducing every instant of time. What you can see if I plot capacitor voltage, it has initial slope, faster slope that we already seen. After that, little lesser slope, then lesser slope, again lesser slope, lesser slope. So overall, my capacitor is following some exponential nature. Okay. So with a means continuous curve, it is like this. This is my capacitor voltage. If this is the capacitor voltage, the output is very well visible, like V in minus VC. So simply it will come to like around 0. So very before the T by 2 it will be 0 because we know that T by 2 is much greater than the RC. The time constant is RC, tau is your RC for this circuit as well, and you will see that T by 2 is much greater than tau. It means my capacitor is reaching to the value of the maximum, which is like a 5 volt, very early. Okay. If a capacitor reaches to the 5 volt very early, then I can say my Vout will also reach 0 volt very early in comparison of T by 2. In comparison of T by 2, my output will reach 0 volt very early. So simply we can plot for the this case like this. If this is my V out, so it is 0. After that, it is coming down to faster. Let's say this is my T by 2. Okay, this is 5 volt into T by 2. And what is happening up T by 2? My capacitor is not there. Sorry, input is not there. What is happening at T by 2? At T by 2, my input is removed or input is made 0. So simply whatever charge is stored by capacitor, it will be discharged. Or at the same moment, my V out will be negative value. What we can see here. Okay. So at T equal to T by 2 positive, what will happen? Excitation is removed. Excitation is removed. So means capacitor reached to 5 volt, but as the capacitor other end is grounded, which is the excitation is removed, but my capacitor was 5 volt already because we have given a lot of time. This is my V out. So what I can say, V out at Ty2 positive will be what? Minus 5 volt. What will the current? Current at this instant will be what? IC Ty2 positive. I'm keeping the direction of current still same because we want this sign there because sign is here. So minus 5 by R is a current. And so slope will be what? Slope at this point will be what? Minus 5 by RC. Okay. Which further we'll see at every instant between these 2 points, Ty2 and T. You will see at every instance, if I consider a few instants here, my capacitor voltage is reducing, hence the current magnitude is reducing. So the slope of capacitor voltage will also be reduced. I mean to say, at some instant, maybe slope from Ty2 plus some T naught amount, it will be like maybe minus 4 by RC, then it will be minus 2 by RC or some value like this. So slope is reducing. It simply means suddenly at this point, Ty2, my output will reach to minus 5. Then again it will trace back. What I mean to say, I should say like this. Okay. So this is my Ty2. So here what it will be minus 5 volt because excitation is not there. So output is just a negative of my capacitor voltage. This is minus 5 volt. From minus 5, this suddenly reduce to this and again it will reach there. Now the same thing will repeat. Okay. So this is our output response for this particular case when my T is much greater than RC or Ty2 is much greater than RC. Then this is your output plot. Accordingly, you can see what will be your current plot and what will be your VC plot. This we have already discussed here. Okay, so we can see it. Now the second case comes when T is much less than RC or I should say Ty2 is much less than RC. It simply means we are not giving much time. We are not giving enough time to charge capacitor in one cycle. Okay, so it will take many cycles to reach at some steady state value for the capacitor. Because we are not giving the time. So again, circuit is same. R, C, out, V in a simple word. This is my Ty2, T, 0, 5 volt. Okay. So Ty2 is much lesser in comparison of RC. It simply means when my input is taking excitation from a T equal to 0 positive or when my input is taking excitation from 0 to 5 volt, again we are having shorted cap. But we'll see that till the Ty2, my capacitor is not getting much time to charge fully. So let I should say it is charging to very lesser value till Ty2. Okay. So simple mechanism is that same will follow all these steps as we have followed previously. So let's say at T equal to Ty2, my capacitor reached to let's say 0.1 volt. Okay, very lesser value it is charged to. Okay, so what I mean to say, if this is my capacitor voltage, because I am not giving much time, this is my 0, this is my Ty2, this is T. So it is reached to like very lesser value somewhere here. Okay, so it is 0.1 volt. Okay, so after 0.1 volt, what happened? We will see that at Ty2 it reached to zero point 0.1 volt. So what my V out? My V out reached to. I am directly going to Ty2 because I want to say here that I'm not going to repeat the same process that what happened at T equal to 0 positive, then T equal to T naught, T1. This already we have discussed. but I'm considering at T by 2, my means capacitor charge to zero point 0.1 volt, which is a very less value. I'm just considering in comparison of 5 volt, it is like a very less value. Like a means some means tenth of the 5 volt, order of some tenths of, or 5 volt divided by like whatever you can say, 50 nearly. Okay, so here what we are doing, what simply 5 minus zero point 0.1, it comes to be 4 point. Okay, so it simply means we can write our V out as, means in this time till T by 2, it was previously 5 and it slowly reached to only 4.9. Okay, so that is 4.9. So we are seeing that it will take a lot of time for capacitor to charge as usual. On the other hand, my output will also take very much time to discharge from 5 volt to 0. Okay, so what will happen at t equal to t is positive? So we can see, okay, so okay, it is just before t. I should not say t positive, t to positive. Rather, I should say it is till the time t by 2. Then like that. Okay, because at t equal to t by 2 positive, my excitation is removed. So simply my V out will be what? V out will be minus 4.9 volt. Or my VC will be what? It is again what we are seeing, because VC is what? Because VC we are considering in this direction. Remember the directions always. This is the VC, this is the V out. Okay, this is the V out. So as I am saying, the VC is reached to zero point 0.1 volt. So when my excitation is 0 at t equal to t by 2 positive or t by 2 just plus point, so my output is reduced to minus 4.9. So simply it will come here. And after that, again, the excitation is not there till the time t by 2. Sorry, till time t. So from t equal to t by 2 to t, my excitation is not present. So I can say my capacitor is discharging, but it is discharging very less. Okay, I'm immediately discharging or discharging like from zero point 0.1 to, because time constant is still very large now. So I can say from zero point 0.1 to let's say 0.08 it is reaching. Accordingly, my output will be adjusted. So when you means repeat the analysis for a long time, what you can see, just I'm giving some rough numbers for VC. Let this is T by 2, T, 3T by 2, 2T, 5T by 2. So this way. Let my capacitor reaching to zero point 0.1 volt, after it was discharging to some value, again to reaching some higher value, some lower value. So this way my capacitor voltage slowly trying to reach its steady state. Okay. So this is the capacitor voltage. So cap voltage is slowly trying to reach steady state value. Okay. Accordingly, we can have accordingly we can have the V out plot. Okay. So I'm not discussing all the things because these type of discussions happened many times in the previous videos. Okay. So this is the discussion for this tutorial. In the coming lecture, I'll take different problem so that we can learn things in terms of different circuits. Maybe I can take time constant calculation, because for many RC circuits, this is a simple two element RC circuit. When there are many elements like 2R, 3R, or 2, 3 capacitors are there in the circuits, then it is really tricky to calculate the poles and zeros. So in coming videos, I'll take these problems. So as of now, we are covering simply two element circuits, which are 1R and 1C. just a different orientation in last 2 3 videos. So I'll continue with these videos. So this is enough for this lecture. Thank you.